Topic 6-4, graphing y equals ax squared, and also graphing an x squared when shifts occur left and right, up and down, big and small. So there are lots of things that can happen on a parabola. You can look at some other examples of this even in the technology lab on page 612 in your Holt textbook, chapter 9, section 4. And also given lots of color examples on page 613. But again, looking at mathisfun.com and going to the quadratic equation, I think it's an evaluator kind of thing, that it'll show you graphically this happening even more colorful than our calculator. Okay, so look at this first one. If I put in these values, and it's asking you to do the same, if you graph on your calculator, y on y1, x squared, y2 put in 2x squared, and y3 put in 5x squared. What I've done is I've put them in this calculator, but if you move the cursor all the way to the left of the y, you can actually change the line. Like if I wanted to make the first one, maybe I think there's a dotted, there we go, so a dotted line. And then I'm going to make the second one a nice thick line. Notice by just hitting the enter key, it changes the style of the line that's going to be drawn. So watch carefully. When I graph this, it's going to start with x, the first one. It actually went pretty fast. So this one is y equals x squared. The big thick one was 2x squared, and then the regular line was the 5x squared. So notice what the change is off of the parent function. This y equals x squared is called the parent function. And so from that, as the numbers get larger, the number in front of the x squared, then the graph actually gets narrower. Lots of standardized test questions on this very thing. As the number in front of the x squared gets larger, it's opposite of what you would think, then the graph actually is getting narrower. So we can do the same thing with leaving the first one, but change this to 1/2 x squared, and then make y3 1/5. So we're actually getting smaller every single time. And notice what's going to happen with these. I've kept my drawings the same, but watch carefully because it's going to go kind of fast. The first one, the second one, and then the original one. So my original one was the dotted line. That's just your x squared. And then the half is the one in the middle, represented by the thick line. And then the outside, just a regular line, as it's getting closer and closer to a flat line. So I tell kids, if they'll kind of think of it as just getting closer and closer to a zero slope, I mean this thing will flatten out to a 0. So as it gets closer to that value, in other words, the number in front of your x squared, the number is getting smaller, but the graph is getting wider. So again, look at those. If you want to see it in a more colorful way, this can actually be shown graphically on mathisfun.com. Okay, the other thing we talked about was what happens when it's a negative. So on your graphing calculator this time, we've got x squared, and then here, let's clear everything else out. This time put in negative x squared. Now watch what happens. I'm going to make this one the thick line. It went away being thick. So let's see, make it a thick line. So my y equals x squared is dotted, and the other one's pretty thick. So when I graph that one, notice what happens. The graph is no different as far as shape. It's exactly the same shape. It's just that if it's a positive, it goes up, and if it's negative, it goes down. So this is a y equals negative x squared. Lots of things to remember. Oops, I didn't realize that wasn't in the view. A lot of things to remember on these. That you can always use your calculator in whatever equation is given to you, But we're going to go through some examples of just trying to look at the graph and decide what the equation would be. But let's look at one last thing. If you have x squared with a positive shift, notice what happens. I'm not going to actually graph this one, but you're welcome to. This is y equals x squared, and as I add to that x squared, not in front of it, but addition, not the coefficient, it actually shifts up. 1, 2, 3, 4, 5. If I add a negative, this whole parabola doesn't change shape, it just moves downward to a -5. So the shift and the change is up and down when you add or subtract. So if we're looking at the equations here, this is at 0, and at 1, the y value is a half. Let's see if that's true. If this is my 1, this is my 2, this is 3, so use the dots to help you here. So at 1, it's a 0. So if I put in a 1 and square it, then it's actually going to be 0 when I'm at 0, 0. So this is actually 0, 0. 1, it's going to be a half. So it's 1/2 x squared. Okay, look at this one. If I'm at 1, the y value is 3. 1, 2. Kind of. It almost looks like, no, that's 2. This is wrong. It was originally a 2. It's not 3. This is supposed to be a 2. So the y value is 2x squared. So notice the vertex is down. So it's down at 2. So I had to shift off my parent function. Always remember your parent function is y equals x squared. And where y equals x squared is examples of here up here where it was at 0, 0. Your starting point is 0, 0. But this, however, shifted down 2 units, but it still is a parabola that's just x squared. This is a negative x squared, but it's shifted up 2 units. Notice the vertex is at 2, positive 2, whereas this was at negative 2. Let's do a few more. There's a whole page. Well, actually, it's going to be in section 6-5. We're through with that section.